Good morning, good afternoon, or good evening, depending on where you're listening. Welcome back to AI and the Future of Work. This is your host, Dan Turchin, advisor at Insight Finder, the system of intelligence for IT operations, and CEO of PeopleRain, the AI platform for IT and HR employee service. Thanks again to all of our loyal listeners for helping us turn this passion project into one of the most downloaded podcasts about the future of work. Keep those comments coming. If you like what we do, share, like, promote, amplify in your favorite podcasting app. It means a ton to us to get your feedback. Now, we talk about AI augmenting humans, and oftentimes in a way that's kind of wonky and sometimes a little abstract. Well, today we get to learn about how AI is applied in one specific industry, construction. Optimization and simulation is an incredibly sophisticated field that's used in everything from manufacturing to workforce planning to retail store design. That's actually what I studied in college as an industrial engineer, and preparing for this discussion was kind of fun. It made me nostalgic about my days programming in MATLAB and in SimCAD. It's a long time ago. Thankfully, the technology has come a long way. Rene Morkos is a one-man army reinventing this space using AI-based simulation software to automate the process of scheduling for construction projects. Alice Technologies, Rene's company, is the world's first AI-powered construction simulation platform. He founded the company in 2015 based on research he had done at Stanford. Alice leverages AI to analyze a project's requirements and then generate efficient schedules. Rene is a Stanford professor, a self-professed construction nerd and entrepreneur. He's been obsessed with construction about his entire life. As the project manager of various construction teams early in his career, he observed how low productivity can be really detrimental on job sites. He took those observations, conducted some studies that really confirmed only, in his words, about 3% of a construction site's space is actively utilized for construction. For the past 6 years, Alice and the team have developed the world's first generative construction simulator with the goal of increasing job site productivity by determining the best way to schedule all the work that goes into a complex construction project. Let's jump in and learn from the expert himself about the future of AI in construction. Rene, it's my pleasure to welcome you to the podcast. Let's start by having you share a little bit about your background and that self-professed love of construction from the earliest years.
What a great introduction. It's great to be here, Dan. Thanks for inviting me. My background, I'm a second generation civil engineer. And so growing up, I got to watch my dad. He had one of those old draft tables and he would draw stuff up on them and he'd go to construction sites. And, I remember he always was super proud. He would like drive by some kind of project that he built and point at it and be like, I built that, or I built that thing. And I remember there was this issue and I remember the owner did this. And then, when I graduated high school, he gave me a good piece of advice. He said, "Hey, son, study anything you want, just don't do civil engineering." Right? So I said, "All right." I was a little bit lost at what I want to do with my life, but I have been enlightened. So obviously picked civil engineering. I like building stuff. I do. I would cut class. I didn't like the structure analysis. Listen to some professor drone on, and I would cut class and I'd go to construction sites and build things. And I would find the cool projects in town and go knock on their door and be like, "Hey, do you guys want some help?" And they usually say no. And I'd say, "What if I work for free?" And they'd be like, "Okay." And so I kind of got to work on some cool projects, and they'd kind of give me a little bit of beer money at the end of the month, usually. And so that's how I started. I started an assistant site foreman. First job out of college, went to Afghanistan. It's been in the news a lot lately. Spent 13 months as a private contractor working for a German company. Slogan was, Hara Construction Afghanistan, take it easy, we'll build it again. Right? So great business model, lots of repeat customers, as we used to joke. I did that for 13 months, got to play the role of the master builder. So design my own projects, A to Z, procured my own projects A to Z, built them from A to Z, right? Really kind of I could change the design in the evening, give it to my foreman in the morning, and kind of change course. Really valuable experience, and I got to see a lot of problems, right? And the one thing that kind of struck me was there wasn't a tool that would tell you the best way to build something. And that kind of surprised me, right? I remember trying to sequence 30 people to build this landing strips for F-16s, kind of a cool project, but a slab is a slab, right? And I kind of remember thinking, man, I got to be stupid. Like, I can't figure out the optimal way to do this. And years later, when I started my PhD at Stanford, I started to look at this from an algorithmic perspective and AI perspective. And I realized, like, oh, wow, this is a really complex problem, right? Like, when you want to, figure out what 6,000 people are doing on a construction site every day for, 3 years, there's a lot of complexity, right? To give you an idea, you're burning through $1.6 million a day. You got 6,000 people out there, 2 million documents to get produced and managed and shuffled through that project over the course of its lifetime, right? Usually about 60, 70,000, items that are, semi-built, prefabricated. They're sitting in your construction yard, never mind all the other material that goes through it. So that gives you an idea of the scale and the complexity of what you're kind of managing in those projects. And so, like you pointed out, started looking at construction sites, realized that space was really underutilized. Literally drive down the highway, look at a construction project, it tends to be empty. And so measured that 3% of space was used for construction on average. So I figured, hey, if I increase that, that'll lead to efficiency. So started developing algorithms that would increase space usage, and kind of somehow stumbled back upon the original problem, which is how do you get to figure out the whole thing, not just space usage? How do you, sequence labor and equipment and materials and calendars and all that stuff? And so, yeah, one thing led to another, and ended up founding Alice. We built the world's first generative construction simulator, right? And I'm happy to tell you about that in detail. But that, I think, is a good sort of introduction to my background and how I ended up doing this.
So Renee, I'm going to bear my ignorance right up front. I have images of construction sites as being dirty places, and I picture dudes with hard hats carrying around lunch pails in overalls. Not exactly the environment that I envision cutting edge algorithms being used with AI models to optimize anything. Who are the people on the construction sites that are ready to use technologies like what Alice develops? And just talk me through kind of the culture of introducing high tech into a construction site.
I'm so glad you said that. It's kind of this thing that nobody really kind of, nobody hits the nail on the head, so to speak, right? Everybody kind of has this vision of construction being unsophisticated. You're absolutely correct, right? Here's what's happening to the construction field. What's happening in the construction field is what happened to manufacturing back in the 80s, 70s, 80s, right? If you talk to somebody that was in manufacturing, say in the 20s, 30s, manufacturing was the same. It was a overalls, dirty job, covered in oil, working 16 hours, in some, windowless factory, and that was kind of how people looked at it. Today, when you think of manufacturing, like, oh, it's this high-tech field, robots, AI, all this stuff. And that's what's happening in our field. And so that's one of the things that I really kind of put my career into, which is, enabling that or making that a reality, right? And so to answer the question of who or how, these companies, use this technology, first of all, when we started, that was 2015, there was still maybe a little bit of, okay, these are old school companies doing it in an old school way, not really too keen on innovation. There was a big change in 2017, 17, 18, I call it the renaissance of construction, right? About $140 billion of venture capital got poured into construction tech, right? And companies we talked to today, I mean, you'd be surprised, right? I've gone to companies, looked at their innovation stuff and, called, the professor at Stanford and been like, you've got to check this out. Like, these guys have PhDs, they've got, machine learning, visualization algorithms. Like, this is a, highly sophisticated, R&D capability, right? And I'm not saying that that's all the players out there, but the beautiful thing about innovation is that it's available to everybody, and the costs are relatively the same. You've got to be able to deal with failure, right? You've got to be able to deal with uncertainty, and you've got to be, put yourself in a mindset where you're gonna have to try something 3, 4, 5 times before it works, right? And whereas when it's known, you can kind of do it once, maybe, or twice, right? And so if you are willing to do that, you will have a competitive advantage. And like in any other field, there are innovators, there are people that are competitive. We were lucky, when we started doing business, we were working with companies like Parsons, like DPR, like Mortensen. These are companies that have been known to innovate and continue to innovate, right? I think that now there's other players that are entering the marketplace, right? And like in every other field, right, those that don't innovate will perish, right? And it's, I think, especially true now because there's so much change being introduced. The construction industry as a whole is being digitized. Incredible opportunity, right? And it's to any of your listeners, when I started working construction scheduling, I mean, this is, there's probably 20 people in the world that would find it sexy, right? But that's where the opportunity lies, right? Like when we finished, when I kind of look back at it, and I'm like, wow, like, is it possible that like such a huge field that has been around for really the entire history of the human civilization, like, is it possible that there's that much opportunity to innovate and apply technology? And the reason I sort of thought that is like, does that mean that other fields have, this big of an opportunity? And I'm convinced the answer is yes, right? Go look where the innovation isn't happening. Go look at where, it's quote unsexy or uncool or considered to be stagnant, right? And I'm sure you will find, readily available opportunities to apply, other techniques and technologies to that field.
So make it real for our listeners. Talk us through an example of how the generative construction simulator is used. Like, what's it simulating? And yeah, I just envision a lot of uses for AI and machine learning around a construction project. What's Alice specifically doing?
Yeah, it's a great question. So people think that Alice, the technology we developed, is not possible. What's kind of interesting is that even today, I have people tell me like, "Oh, it's not possible." Like, no, I call BS. You guys, you don't have it. And there's several reasons for that, right? One of them is that construction is too complex, right? Like there's too many complexities, right? There's rain and hail on a Thursday, and overtime, it's Christmas, I can't work, I'm using fast drying concrete, cranes are different radii, production rates are different, materials, labor, equipment, like all these things come together, and it's not possible to simulate, right? It's not possible. How could a computer do what I do in my head? It's not possible. And so another reason why people say it's not possible is that it's really big, it's very complex, right? Like, I mean, a typical construction project, 6,000, 10,000, 3,000, 15,000 tasks, right? And so you're like, okay, it would take way too long for me to set up 6,000 tasks in the machine for it to crunch it. Another challenge that I'm sure you've encountered is this issue of trust, right? When you have an AI algorithm that goes through a bunch of data and it says, hey, this is the best way to do it, a lot of times it's like, well, do I trust it? How did it come up with that answer? What's the thinking behind what it's doing, right? And so here was our approach to basically solve these three challenges. The challenge of it's too complex, the challenge of it's not scalable, right? There's too much data, like it would take me too long to set up such a system, right? And the challenge of I don't believe it, I don't trust it. And so here's what we did. I'll tell you what we didn't do. A lot of people think that what we did was we took the algorithm and then pointed it at existing schedules, at existing, completed schedules of projects, right? And then we looked at, 40,000 schedules, and then the computer kind of, woke up one day and said, oh, okay, I've looked at 40,000 schedules and now I know how to build. And I'll tell you the 40,000 first one I'll generate for you. The issue with our field, right, is that there isn't anywhere to learn from. We don't even have a fully developed information or data model that underpins our field. I've had people from the computer science department come to me and say, hey, we want to go work on something in construction. Can you show me the book that will tell me like what are all the little pieces of the puzzle? Right? What is the data model that you guys use? How do you guys think about construction? And the truth of the matter is that we don't have one that's readily, made. You can read a whole bunch of books and piece it together, right? But there isn't one that's fully worked out. And so what I'm trying to explain is that there isn't enough information to learn from, A. B, when the humans weren't involved in the setup, they don't tend to trust it. And so the way we solved it is we said, hey, here's what we're going to do. We're going to give you effectively a way to, and we're going to separate the rules that govern your project from the solution to those rules. We're going to split planning from scheduling. We've learned that we shouldn't call it scheduling, we should call it simulating. So we've split planning, creating the rules, from the simulation, crunching the rules. And when you start to think about it, you're like, in hindsight, it all makes sense. You're like, yeah, it does make sense, because what are humans good at? Humans are good at communicating, collaborating, gut sense, understanding reality, risk analysis, experience, prior experience. Huge, huge deal. You do not want to build a system that doesn't, leverage the human ability, right? And so what you do is you set, the first step is you set up the rules that govern the project. We call that planning. The rules that govern a project, you're like, well, that sounds abstract. It's not. What are the, you want to build, the project has 100 columns. Well, what do you need to build a column? Well, I need to put some steel, pour some concrete, dry the concrete, strip the formwork. These tasks require these resources. I need carpenters, I need steel workers, I need a concrete pump. Great. We call that a recipe. The recipe gets applied, created once for a column, and then applied to all the columns, right? Another rule is, grouping. So I'm not going to, build this thing column by column. I'm going to put all these, 10 columns into one group and say, hey, build that in the next week, right? So there's, 2 or 3 rules that we sort of developed, and that's kind of what I did in the research. What I did was I boiled down, and I don't know if I'm getting a little bit too technical here, but I converted complex construction constraints into generalized scheduling constraints. So that's kind of one of the tricks, which was, the complex construction constraints, there's thousands of. It turns out that you only need to convert them into 3 general scheduling constraints. That kind of surprised me, right? So you can convert that whole problem into its essence, and there's only 3 essences, if that makes sense. So that was how we got around the, construction's too complicated. Sure, but you can boil it down into relatively simple things, right? And so that planner, right, is the part that never existed anywhere. We invented that from scratch. That's, I think, the key reason why people are like, hey, it's not possible, because they don't think of it in terms of, hey, I'm going to set up these rules within a planner, right? So you set up these rules within the planner. You then basically say, okay, let me go crunch those rules. I'm going to send that to the computer. The computer crunches those rules. That's what computers are good at. When you think about it, computers are really good at one thing, just crunching data, right? It's good at that. Computer crunches, you send, whatever, 40,000 constraints, does all the crunching for you, generates millions of solutions. That's kind of the cool thing, is that usually there are multiple solutions, right? That's not apparent to human operators because they're used to generating one option. But your rule set will have millions of solutions that satisfy it. The software automatically filters out for the fastest and the cheapest. Then you're like, okay, you can click on a dot, expand it, view it in detail, right? So it gives you a little video of how it gets built. It gives you a schedule that's automatically generated that you're accustomed to seeing, and advanced analytics, which crews are being used when, what's your utilization rates and your resources and things like that. So those are kind of the 3 phases, right? And so you set up the rules, let the computer crunch the rules, and then you can interpret the results. Notice, by the way, that doing it this way, we got around the construction is too complicated. We got around the scalability, because we are essentially, creating 10, 15. This is how you build a column, apply it to all 100 columns. This is how you build a slab, apply it to all 30 slabs, right? So you create, say, 10 or 15 of these recipes, they generate 3,000 tasks, right? And the last piece is the trust issue, which is, I've seen this many times, like the final presentation of the pilot stage, the people that ran it, of our client, they'll be sort of pitching it, and then they'll say, hey, what they'll say is, hey, Alice showed us how to save 17% on duration. And, the CEO in the room puts their hand up and says, hey, why do you believe it? And there's always a kind of confused look of like, well, I told her how to do it. I told her this is what I want, if that makes sense, right? And so you can tweak the rule and in real time see the impact. And that feedback loop, like, if I've got two buildings, I have one crane, building A goes up, building B goes up. I add a crane, both go up at the same time. That rapid feedback loop increases the believability in the system. And so that's kind of how we've pieced it together, right? And when you think about it, you're in the first, what AI does over and over again, and we started to refer to it not as artificial intelligence, but IA, intelligence augmentation. Over and over, we've seen it at Stanford, right? The software, the AI, or whatever you want to call it, gets developed, and this human becomes not the entity that does the number crunching, but the entity that sets up what needs to be crunched. The computer crunches it, and the human then interprets the results, right? And there's a feedback loop, and that's kind of what you're seeing with Alice.
It seems to me like each construction site would be unique enough that you'd have to train models specific to each project. If that's the case, are there some projects that aren't good candidates because they don't have the required data?
The truth is that the data lies inside people's heads. And so what we have, this is what we have that's kind of unique, right? It hasn't been done. What we have is a translator. Like, I have a tool that allows you to translate those rules that are in your head into what the computer can understand. And it does so visually. You don't need a PhD in operations research. It's very intuitive, right? And does so scalably. That's what we've got. We have ability to capture the rules in somebody's head and put in the computer. So what we're applying the artificial intelligence and machine learning, but we apply it to the crunching, if that makes sense. So we figure out better ways to sequence the work, but the rules, those come from the humans. And I'm convinced that's the right way to do it, because once the humans are not supplying you the rules, they're not going to really believe the results, right?
How do you mitigate for the impact of biased data coming from someone's head as opposed to data captured from a theoretically unbiased system?
Yeah, that's a great question. There's kind of two answers I can give you, right? The first answer is that because of the fact that the software requires a little bit of a collaborative approach, right? And it rapidly generates videos of how it gets built. You can filter out various comparisons, that you can filter out the critical path. You can, look at various important angles of the data, the utilization rates. You can compare options together, right? So what I'm trying to explain is that it rapidly gives you insight into the solution that you created and the quality of that solution, right? That is one. Two, there will be some bias that is encoded into the software, and I think that is the correct way to do it. And to give you an example, let's assume that I was supposed to start construction in June, but the permit didn't come in, and now I'm going to start in December. Well, guess what? I know that there's a lot more rain in December, and so I need to tweak the production rates for my soil related activities, right? And so that's a bias that I want to introduce in the system, right? What you'll start to see is that humans, they're really good at this sort of gut sense, risk kind of, gray area analysis. And so what a human can do is a human can say, hey, I'm going to take buffer from here and put it in here, or vice versa, right? And so you want that, right? I think that is the correct way to go about it.
We often talk about the ethics of AI and machine learning on this podcast. And one of the concerns I would have, which may be unfounded, but let's say I'm a 4-person on a site, foreman, 4-woman, and I for whatever reason, I may have a preference for a particular supplier. And let's say I may have a preference for a supplier that's not minority owned as opposed to one that is. It seems like it would be easy for me to introduce my own bias into the process, which could obviously impact the decisions that Alice is recommending. They could be suboptimal because of some bias in someone's head.
That's an interesting thought, right? I don't see how, if you prefer one supplier over another, what the software is going to do is it's going to take information from both the suppliers, run it, and then give you the best option, right? the supplier has concrete that dries in 6 hours, that one has concrete dries in 8 hours. The software will run both and then say, okay, here's the solution, right? Kind of wondering if there's any other examples I could
as
think
long
of.
as there's full fidelity of the data. If I
Correct.
chose
Yes.
a
Right.
biased sample of the data, potentially
Correct.
could
Yes.
introduce bias.
Yes. But that's not something like, if you, okay, so I guess, you know what, here's a different twist that I've seen to it that would come into play. What's really interesting is that the software is capable of, here's what it kind of does is it allows you to build your building 30 different times before you have to go build it, right? So that's a big deal because it's a simulator. It's not a scheduler. It simulates the project. It actually builds it for you. You say add a crane and it rebuilds it. Add a crew, it rebuilds it, right? And so you're saying, okay, so if you simulate this thing, over and over again, what we suddenly realized was that humans that are running it won't show all the data to the other humans that they're working with, right? And so that's starting to tell you there is the system is being used to bias a decision, right? But humans are human, right? You will tend to use a software to support the story that you're trying to sell, right? And is that the ethical thing to do or not, right? The counter argument is, well, I'm a human. I know that the 3 crane option might be faster, but it's opening us to more risk because of XYZ. I really think we should go with the 2 crane option. It's a little slower, but we got more buffer in the thing. So
essentially what you're saying is, as long as I'm optimizing for the right outcomes for the project, it would be hard for me to introduce personal biases in the project without having suboptimal outcomes for the overall project. Cost and risk and time and things like that. If those are what I'm optimizing for, then I have a strong disincentive to introduce biased data.
Correct, but I'm also saying that what we're seeing is that there's also an incentive to bias the data in certain cases, right? And I don't think that's a mistake. I don't think that's wrong necessarily, right? Because somebody with experience, like, you're trying to leverage a computer machine system, right? And I really don't believe that you want only human or only machine. The two together, that's where that's what knocks out the ballpark. That's incredibly powerful. And the combination means that let the machine do the crunching, right? But the human can do the gut sense, risk analysis, or in some cases biasing, right? Because that's what humans do best. And so, yeah, I think that as long as you have humans involved, there will be some shifting of the data or moving the software towards a certain area of solutions, right? And I don't necessarily think that's something that's wrong, right? To the contrary, I think 90% of the time it's it's not 95% of the time it's the right thing to do.
So construction tech has been a hot thesis, at least along Sand Hill Road, the venture capital set, for years. And it's produced some high-profile successes and some high-profile failures. I'm thinking of Katera, and lots of ink has been spilled about the challenges in introducing technology into construction. When Alice is wildly successful, you're looking back on this in the rearview mirror, and you and Alice have proven that construction tech works. How is the process of building, of constructing things different when we think technology first, and we've gotten past this kind of early experimentation phase?
I think there's a new ecosystem that's coming at us in construction tech. I think the fundamental value proposition of general contractor is changing. I think that the game is going to get kind of decided by 30 to 50, maybe 100 players, right? That are aware of this change and are going to ride that wave over the next, I'd say, 10 years, right? It's going to be pretty quick, in my opinion. This new ecosystem that's getting built, its fundamental currency will be data. And what you're going to start seeing is that each of these companies, ours included, and there's many others, right, is digitizing a part of the construction universe. at some point you'll start to reach a tipping point where enough of that construction universe is digitized where you'll start being able to. One of the biggest problems in any resource intensive industry is fixed capacity. What you'll be able to start doing is shuffling that capacity, from project to project, from company to company. Right? You'll know that somebody canceled your order, but someone else needs that material, right? Or vice versa. Somebody ordered something, but you can persuade them to kind of take the delivery in 72 hours because you can resequence their work. You can, you know, uh, schedule projects where you have a lot of resources available one day and very few the next day, and very a lot the day after, very few. You give variable capacity, right? Because you can move that capacity to other projects when you don't need it, right? You can start sort of doing those kind of things. I think that what will start to slowly happen is that you will start to introduce a world, in construction where here's something that I think will start to happen, that the best construction folk will start to get paid multiples of what the average folk are getting paid, which is not necessarily the case today, right? Because you will start to enable, like, I wouldn't be surprised if you reach a point where, you know, you could have a construction project where, a smart graduate, like in finance, right? A smart graduate that joined, I think it was like Chase One or Capital One or whatever it was, they were hiring folks, 15 years ago that were, developing algorithms that would maximize return on borrowing, right? And I wouldn't be surprised if you reach a point where, young graduates would come in and sort of, develop their own algorithms to optimize certain parts of this construction project process, right? I think that we're heading towards a reality where the field is going to become increasingly more sophisticated and the application technology is going to be, prevalent, right? And so I mean, I don't think that we're going to reach a point where people are going to be walking around in lab coats, right? But it's almost to the point where, you know, robotics, it's happening, right? The supply chain is getting digitized. It's happening, right? You look at, Autodesk's, purchasing of Building Connected, right? For precisely that reason, right? $250 million acquisition, right? Um, Basically, what I think we're going to end up with is a field that is highly sophisticated, highly technologically advanced, and attracts people that want to apply cutting edge techniques and technologies. Today we call them AI and ML, and that's kind of what we're calling them. But those names will change as we move forward, right? But it will still be that kind of bleeding edge of technological advancement, right? And that's going to get applied to our field. So that's where I think it's headed.
So I envision a scenario where, kind of like what's happened in the operating room with doctors using, robotic arms, like what Intuitive Surgical has done for surgery, potentially something like Alice, or your companies in your cohort could do for construction. Is that science fiction, or is that a reasonable analogy?
Oh, it's happening. Like it's happening now. The thing that's really exciting is that every person, no matter who you are in the construction industry today, you can play this game. And it's like, okay, well, some folks might think, well, I'm in a construction company, what can I do? The truth of the matter is that these startups, they're just outsourced R&D departments. That's why we exist. I thought about this a lot, right? And so, what's happened is these large companies today, this R&D thing is really risky. Let the VCs take the risk, right? Let the venture capitalists take the risk. We lose some control, but now instead of having one R&D department, we got 50. And the name of the game is integrating these R&D departments together, right? It's going out and saying, okay, well, if we're going to use robotics, we'll use, for example, a canvas, right? They have robots that do drywall. Well, how do we schedule it in? Well, there might be some parts of the drywall they can't do, so we need some humans to finish that piece. How do we schedule it in with the rest of the work? How do we, and then we're going to use something like Versatile Natures to collect data, right? Or Doxel. We're going to use Alice to schedule. We're going to use, there's all these kind of bits and pieces of the puzzle. And the name of the game is integrating it and building out the underlying, I guess, data structure, data schemas of how those systems will communicate within your company and what kind of dashboards or analytics you can kind of provide yourself and your team, right? Incredibly exciting. I mean, really, on the one hand, I'm sitting, developing this AI technology. On the other hand, I'm looking at folks that I know that are doing companies, and it's a fun job. It's a really, really fun time to be in construction, right?
René, I got to get you off the hot seat. We're way over time, but not without one last question. I was curious about your entrepreneurial journey. So, what has surprised you most? Is it kind of the people management, the fundraising, sales, marketing? Like, what do you wake up and be like, man, I didn't sign up for this?
I gotta admit, like, maybe on a personal note, what surprised me is the brutality of it, right? It's really like it's 24/7, right? I mean, it's been now, like, I guess here's one thing that surprised me. It's I wish, like, you are going to be talking, if you were going to go found a company, you are going to be talking about that company like all the time. Like, you go to a cocktail party and people ask you about it, and you talk about it, and you're like, it's the one thing that you're doing all day, every day. It's been like 13 years, right? And so, the it's definitely, not an easy journey, right? And I spent a year in Afghanistan, and I, mountaineer, so I guess I picked these, challenging things. But yeah, I guess that's the one that was surprised me, right? It's just 24/7, right? And it never seems like, you can, like, step away for an hour or take a break or something, right? It's always screaming that it needs like X or Y or Z. There's always some like huge thing that it needs, right, currently. So yeah, I mean, that's the one thing that I would, share with anybody that wants to do it. Like somebody once told me, the highs are high and the lows are low, you know. And like on that, like, one day of the month where it all clicks together, it's just this incredible feeling, right? And then you spend like, 25 days, just kind of slogging it out, right? So that's kind of the nature of the game.
It's so raw and so real, and just so accurate that it's an intense journey. And as someone who hasn't been a part of an entrepreneurial journey, you just cannot describe the intensity, the commitment.
Yeah.
Everyone uses the cliche about being a parent and raising a kid and that sort of thing, but it's even more intense, and it's relentless, and and it's such a drug, because like you said, on the good days, when you can sit back and be proud of something that was just a thin strand of vision that you extracted from your head, there is no better feeling in the world. And it's worth all of the down days, just to experience that thrill of doing something just transcendent, with a small team. And just love the way you describe that.
Highly, recommended, but be careful.
That's right. Well said. Well, René, you've come a long way since building airstrips for F-16s in Kabul. Congrats on all the success.
Thank you. Thanks a lot. Really enjoyed the conversation. Thanks for having me. And yeah, all the best to everybody listening.
Well, I'm looking forward to watching the space grow, and of course, watching you and Alice achieve more success. Maybe we'll have another version of this conversation sometime in the future. What do you think?
Yeah, absolutely. Anytime. Love to do it.
Good stuff. All right. Well, thanks again to René from Alice Technologies. Great discussion. This is your host, Dan Turchin, signing off for this week, but back next week with another fascinating guest.